Welcome everyone. In the previous lecture, we were discussing the malloc example, and we were discussing that what is the output of this program. And I guess majority of you were able to give the answer that here, whenever we are printing, it will give the output 10, 20, 30, 40, and 50. Okay, so I think we have covered up to this. And now we'll go to the next slide, that is Calloc allocating multiple memory blocks. As we know that malloc allocates memory which requires only one argument, where Calloc will require two arguments. Calloc will allocate multiple blocks of memory of uniform size and then sets all the bytes to 0. Normally used for requesting memory for derived data types such as array and structure. It actually requires two arguments, number of block, that is n, and the size of each block in bytes. Here, for example, you want to allocate memory for a structure variable. Assume that a structure variable is occupying total 10 bytes of memory, and you want to allocate memory for total 10 structure. Then your n, that is a number of block, will be 10, and size of one structure variable is 10. So how we will write ptr is equal to cast type, that is a type cast, and calloc n comma element size. So here it is having total two arguments, one is n, another is element size. The above allocation continuous space for n blocks of each element size. All bytes are initialized to 0, and the pointer to first byte of the allocate memory space is written and assigned to ptr. Okay, same as malloc function. And similarly as malloc, it also returns a null pointer if the memory location fails. That indicates the memory is insufficient. With the use of calloc, we can see some following assumptions. If we are assuming that sptr is a pointer, that is of structure data pointer. Second, size of structure data is, we are assuming 10 byte, that is a byte for one structure variable. And calloc allocates desired memory blocks, so sufficient space in heap, if the space is available in heap memory. So if we write a statement sptr is equal to structure data pointer, that is a typecast, the calloc 5 comma size of struct data. Here the n, that is a total number of element we want to store in the structure, that is 5, and the size of struct data in our case, that is given as 10 bytes. So total 5 block of each 10 bytes, so that is 50 byte continuous. So first allocates 50 byte of memory space for 5 structured data elements. Second, calloc returns addresses of first byte of above allocated memory into sptr, and the return value of calloc, which is again a void pointer, it is now typecasted into struct data, and then it will be assigned to sptr. The next function is free, which is used to release the allocated memory. As we know, on the static memory allocation, the compile time storage of a variable is allocated and released by the system in accordance with the storage class. For example, if a variable is declared globally, then the memory allocated to that variable will be released when the program ends. Another thing is, when a variable is declared inside main, then that variable will die when the program ends, and the memory will be released. The lifetime of that variable will be throughout the main, that is a program. But if you declare some variable in some user defined function, for example factorial, so whenever you call a factorial function, at that time that variable declared inside the factorial function will be alive. The memory is allocated. When the function returns, when the function factorial returns, we know that that is a end of the function call, and the memory will be released for all the variables that are declared inside the function factorial. So based on the storage class, the memory will be released in case of static memory allocation. But with dynamic or runtime allocation, it is our responsibility to release the allotted space when it is not required, particularly when memory is limited. So how we will write the function free and the pointer? In the argument, we need to give the pointer value, that is free PTR. The above statement is used to release the previously allotted memory using malloc or calloc, which is being accessed using the pointer variable PTR. The above statement is releasing the allotted memory being pointed by PTR. So if we consider this case here, in our case SPTR is equal to structure data calloc 5 into size of struct data. Here the memory is allocated and it is stored by SPTR. So SPTR is referring to this memory block of total 50 bytes. So if we want to release this memory, then we need to write here free SPTR. So if your variable name is SPTR, we will write free in the bracket SPTR. The above statement is releasing. Look at the last statement and underlined with blue font. The above statement is releasing allotted memory being pointed by the pointer, but not the memory allotted for the pointer variable. That means it is releasing that 50 byte dynamically allocated, but not the memory for the variable SPTR. It is not releasing the variable SPTR, but it is releasing the memory pointed by the SPTR variable. I hope it is clear. Free. Things to keep in mind when we use free. First, use of invalid pointer may create problems. If the pointer you are writing in the function free, if it's invalid, then definitely will create problems. Second, it is not the memory used for pointer variable that is being released, but rather what it points to. That means that I just discussed that SPTR points to that 50 byte. So actually when we write free SPTR, it is releasing the 50 bytes, not the SPTR. To release an array of memory blocks allocated by Calloc, we need to only release the pointer once. It is an error to attempt to release memory blocks or elements individually. So for example, when we use Calloc to allocate a memory for integers, suppose for example 50 integers, then we will write, what we will write? Integer pointer Calloc 50 comma the size of integer. So it will allocate 100 bytes. So we need to just write free PTR. We should not try to delete the memory individually for each 50 element. So that is an error. The next function is realloc. What happens if you use malloc and calloc and later on you realize that you need to modify the memory previously allocated, whether you want to increase the memory or whether you want to decrease the memory? So there are two cases. Case A, when we allocate memory is found insufficient, we need additional space for more elements. And case B, when we allocate memory is much larger than necessary, we want to reduce it. So the first case, if the original allocation space done by the statement is PTR int malloc, and that is an old size, assume some value, that is for example, okay, it's not taken, so old size, some value, for example 10. Then reallocation of space can be done by the statement ptr is equal to integer pointer realloc ptr, that is the previous pointer variable ptr, that means the previous memory, the pointer variable points to the previously allocated memory by malloc, comma the new size. So for example, the old size is equal to 10 and now I want to make it 15, then I will write ptr is equal to, here I will write ptr is equal to integer pointer malloc 10, so 10 bytes allocated. Now I want to make it 15, then I will write ptr is equal to integer pointer realloc ptr comma 15. So now the new memory allocated will be 15. The new size may be larger or smaller than the old size, so there are two possibilities. If your previous size is 10, then your new size can be 15 or it can be 5. So you, in case of 15 you are increasing the memory, in case of 5 you are decreasing the memory. The realloc guarantees that the old data will remain intact. Whenever we use realloc function, whatever stored previously in the old memory will remain as it is. Realloc, look at the statement here. Okay, ptr is equal to task type realloc ptr new size. The above statements allocates new memory space of size new size. The new block may or may not be begin at the same place on as the old one. We know that we are following dynamic memory allocation and the memory is allocated from the heap area. Suppose initially we are allocating memory for 10 bytes and now we are asking for 15 bytes. So if the next new 5 bytes that you are asking, if it is not available continuous, that means not consecutive 5 free bytes available, then the compiler may decide to allocate the new 15 bytes somewhere else. So in case it is unable to find additional space in the same region, then it will create the same entire new region somewhere else, move the content of old block into the new block. Old data will remain intact, means it will copy the old data from old position to new position. It returns a pointer to the first byte of the new memory block, same as malloc and calloc. We need to be careful here. If the function is unsuccessful in allocating requested memory space, then it will return a null pointer and the original block is freed, that means it is lost. So testing is essential before proceeding. So before you use realloc, you should be careful and you should be sure that the memory is available. If it is not, then you will lose your data. Let us go to the first program. Which will demonstrate the use of DMA. Okay, in this we are writing a code to create a buffer, that is a space memory, to copy a string bala, that will require 5 characters, and then we increase this buffer space to accommodate entire string, that is Bala Gurusamy, additional 8 characters. So you will require a total of 13 bytes. So we are taking two variables, m1 and m2. m1 will have the size 5 and m2 will have the size 13. We will use first m1 to allocate memory using malloc 5 bytes, and then we'll modify the same memory with 13 to store the largest string. This program demonstration I will show you in Turbo C compiler. Okay, so let's go to that. Okay, now you can see the example for Realloc. Here, initially we are allocating 5 bytes to store Bala string, and then we are modifying the same memory and we are increasing it to 13 to store Bala Gurusamy. So here malloc will allocate 5 byte and pointed by buffer we will store bala inside that is using string copy, and then we are reallocating that memory with the size M2, that is 13, to store Bala Gurusamy. But here we are using string cat, so that initially Bala is already stored in buffer, and as we know that the previous allocate data will remain as it is, so in the buffer with having total length now 13, Bala is already there, so we will add Gurusamy, we will use string cat function, so Bala is already there, and then we are adding Gurusamy, so finally it becomes Bala Gurusamy, and then we are printing, so that you can see in the output. Okay, so buffer is created from the address 0648, that is a malloc function, and in that we are storing Bala. Then buffer is created from the address 1618, that is a new address from where we are allocating 13 bytes, and inside that we are storing the string Bala Gurusamy, that is output. Okay, I hope you are getting this. So I hope you got the output from the program and how it is working. Moving forward, we are having a programming exercise. Write a C program to store a character string in a block of memory created by malloc. So how we can go in or write this program in step by step. So first step is we need to actually get the length from the user, that what is the length of the string. So we need one integer variable, integer alien. The user will enter the length, so that we are scanning using scanf %d. Second step, using malloc we can allocate memory of the desired size. So, and as we are going to store string inside that, so we need one character pointer str, character pointer str, and then we write str is equal to character pointer, that is a typecast, and malloc length. So this will allocate total alien number of bytes length number of bytes, and it will, the block will be, memory block will be allocated, and the initial address will be assigned to str. Step 3, once the memory is allocated, we can easily scan the string. So accept the input string from the user and store the same in allotted space using the scanf %s str, so that we can do. Now some important information regarding character pointer and string, that is character pointer str and scanf %s str. When you write, at the time you know that you have just declared the character pointer, but there is no enough space allocated, or the pointer str is not pointing to some valid memory space allocated. So when you are directly scanning this scanf %s str, this statement may incorrectly terminate the program. Reason, the str is not initialized and hence it may contain garbage value. So if the pointer address is containing the garbage value, in this situation scanf may attempt to put the string entered by the user in a restricted memory space and may terminate the program. It may overwrite some data, and that your program behavior will be abnormal. However, in the previous program with DMA, as we have seen, that we are first allocating memory here for the str, character pointer malloc alien. So first the memory is allocated for the str, then we are scanning the string in str. So this will solve the problem. So that is what discussed here. So you can modify the earlier program with DMA to accept the input string of any length. So based on the value you enter for alien, you can enter the string of any length. So you can write this program and you can email me your work, how to write or how to